Hello students, this is the lecture number 2 on differential equation. In the previous lecture we saw what means the differential equation, what means the solution of the differential equation, what is the definition for order and the degree of the differential equation. So in this lecture we will see some more examples over finding the degree of the differential equation. So the first example is, what is the degree of this given differential equation? Okay, so by the definition of order and degree of the differential equation, order is nothing but the highest ordered derivative involved in that differential equation, and the degree is nothing but the power of the highest ordered derivative, but the differential equation should be free from radicals and fractions. So if you'll observe in the example number 1, this term has the power 1 by 2. Okay, this is to the power 1 by 2. So it should be free from the powers like this. Okay, so what we will do? We will be squaring on both sides. So after squaring, okay, so squaring on both sides. So after squaring, what you will get? This will be d2y by dx square is equal to y minus dy by dx. Okay, now this is in the general form of the differential equation, so we can identify the order and the degree of this given differential equation. So the highest ordered derivative is d2y by dx square. So the order of this differential equation will be 2 and its power is 2, so its degree will be 2. We'll see the next example. In the next example, if you'll see, this term is to the power y plus dy by dx raised to 1 by 4. Okay, this is d2y by dx square. Okay, so we don't need this term to the power 1 by 4. So we will raise the power by 4 on both sides. So see what will happen. This will be d2y by dx square to the power 4 is equal to y plus dy by dx squared. Okay, it is square here. Now we can identify order and degree of this differential equation. If you'll observe, the highest ordered derivative is d2y by dx square. Okay, so the order of this differential equation will be 2 and the degree of this differential equation will be the power of highest order derivative, and the power of this highest order derivative is 4, so degree will be 4. We will see the next example. If you'll observe this example and simplify, this is d2y by dx square plus 4x and this whole raised to 1 by 3 is equal to, and this is dy by dx minus raised to 1 by 2. Okay, now the first term has the power 1 by 3 and the second term has the power 1 by 2. Okay, so we will in such a case, what we do, we find the LCM of 3 and 2. Okay, that is 6. Okay, so raise the power of both sides by 6. Okay, so taking power raised to 6. Okay, so see what will happen. This will be d2y by dx square plus 4x. This is raised to 6. This will be 6 by 6, 6 by 3, and this will be dy by dx minus 1 raised to 3 by 2. Okay, so finally what we will get? This will be 2 and this will be 3 by 2 itself. Okay, there will be, sorry, this will be 6 by 2. Okay, so finally what we will get? This will be raised to 3 and this will be raised to 2. Now if you'll observe here, this is like a plus b whole square, and if you'll split this, you will get the term like this, d2y by dx square raised to 2, and this is the highest order derivative and its order is 2. So order is 2 and degree of this differential equation will be equal to 2 itself, because degree is nothing but the power of highest order derivative, okay, and the power of highest order derivative is 2, so degree will be equal to 2. We'll see the next example. Okay, in this example, if you'll observe, we have the term like this. Okay, so we can rewrite this equation. This will be third root of 1 minus dy by dx square is equal to, I will take this minus y to the right side, that will be plus y, and this term to the right side, that will be 2 times d2y by dx square. Okay, now raise the power by 3. Okay, so what will happen? This is raised to 1 by 3. Okay, this term is 1 minus dy by dx square raised to 1 by 3 equal to y minus 2 d2y by dx square. Okay, so raise the power by 3. So see what will happen. This will be 1 minus dy by dx square is equal to y minus 2 d2y by dx square raised to 3. So after solving this term, okay, you will get the highest term as d2y by dx square raised to 3. Okay, so that we can find out the order and degree of this particular differential equation. Okay, so order is the highest order derivative, which is 2, and degree is the power of that highest order derivative, that is 3. Okay, now in this next example, see, again you need to simplify this. This will be 1 plus dy by dx square raised to 1 by 2 is equal to 5 into raised to 1. Okay, so raise the power by 2. So what we will get? We will get this as 1 plus dy by dx square is equal to 5 into d2y by dx square raised to 2. Okay, now this is the highest order derivative and its degree is 2. So order in this case will be 2 and degree will be equal to 2. Okay, now we will see what is the solution of the differential equation. Solution of differential equation. Okay, so as I explained in the previous lecture, the solution of differential equation is nothing but it is a relation between dependent and independent variable. Dependent and independent variable, that will be called the solution of the differential equation. But what relation? The relation which will satisfy our given differential equation, that will be the solution. We have seen y equal to sin x is what? The solution of this differential equation, d2y by dx square plus y equal to 0. So in this chapter differential equation, we have to find such a solution of the differential equation using different method. Okay, so we will see one by see what are those different method to find the solution. We will be finding solution means what? We will find the value for this y in terms of x, which will satisfy our differential equation. Okay, now before that we will see what is the differential equation and how we write the differential equation in general form. Okay, so in general we write any differential equation of first order. Suppose we write it like this: mx comma y dx plus nx comma y dy equal to 0. This is the way of writing the differential equation, where this mx comma y and this n x comma y are functions of x and y. Okay, for example, if we'll take the example for this will be like x square y dx plus sin x dy equal to 0. This is differential equation. Okay, this is value for mxy, and this is value for nxy. Okay, m and n are functions of x and y. Okay, we can take another example, x cube dx plus x square y square dy equal to 0. Okay, so again this is m, and this is n. Okay, so in general any differential equation can be written like this: first order first degree differential equation. Okay, also we can write this differential equation general form like this also. If I will take this mxy into dx term to the right side, see what will happen. This will be n x comma y dy equal to minus m x comma y dx. Okay, see, if I will take this dx term to the left side and this mxy term to the right side, then what we will see? We will see the differential equation like this. Okay, this will be like dy by dx is equal to minus m x comma y upon n x comma y. So any differential equation can be written like this, in this form, or it can be written in this form. Okay, we saw two form of differential equation. Okay, what was that? First, in general we can write any differential equation mxy dx plus nxy dy equal to 0. This is the first form in general, and the second form was dy by dx, this is equal to minus m x comma y upon n x comma y, where this m x comma y and n x comma y are nothing but functions of x and y. They may be constants. Okay, they may be the constant functions. Okay, now what we are interested in finding the solution. Okay, we need the solution for such a differential equation. We need solution means what? We need this y as a function of some x, so that this function will satisfy our differential equation. That's it. Okay, that is what we will do. So out of that, the first method to find the solution of the differential equation is called the variable separable form of the differential equation. Okay, now what means variable separable form? So firstly, we will see what means variable separable form. In short, this is also called VSF form. Okay, so what is variable separable form? So if the differential equation is in the form of like this: dy by dx is equal to function of x upon function of y. Okay, then we say that this is the differential equation in variable separable form. Okay, or if it is like this: function of x dx plus function of y dy is equal to 0. If you'll see in the previous case, what was there? If you'll see here, this mxy and nxy are a function of x and y. Okay, but in this case we have this f of x, right, and this f of y as a function of x and y alone. Okay, what it means, that is, or where this f of x is function of x alone, okay, and this f of y is function of y alone. Okay, for example, suppose we'll see one example for this, like this: x square dx plus sin y dy is equal to 0. this differential equation is in variable separable form. Because why? If you'll see, the coefficient of this dx is what? X square. Okay, it is a function of x alone. This is f of x, function of x alone, and the coefficient of this dy is sin y. This is function of y alone. Okay, so this is what we will learn here, how to find the solution using the variable separable form. Okay, we'll see one more example for the variable separable form. If it is like this, x raised to 4 dx plus log y dy equal to 0. This is in variable separable form. Because why? This is a function of x alone and this is function of y alone. So this is in variable separable form. If I will take this example, x square y dx plus suppose x sin y dy equal to 0. Now question is whether this differential equation is in variable separable form or not. So this I will take as y square x sin y dy. Okay, so this is not in variable separable form. Why? Because this is not function of x alone and also this is not function of y alone. Okay, so this is not variable separable form. Okay, so if you will be able to convert any differential equation, okay, if f of x dx plus f of y dy equal to 0 is in variable separable form, okay, is in variable separable form, okay, then its solution is given by how its solution is given. You just see this what it is. Okay, this differential equation is in variable separable form. Then you can directly find its solution just by taking integration on both sides. Okay, so taking integration on both sides, this will be like integration. This will be like integration f of x dx plus integration f of y dy equal to constant. Okay, so this is how we can find the solution of the differential equation if that differential equation is in variable separable form. Okay, for example, if we have this example like this, x square dx plus y cube dy equal to 0. This is our differential equation. Okay, now question is whether this is in variable separable form. So you just need to observe this function. If this is a function of x alone, answer is yes. Okay, if this is a function of y alone, yes, answer is yes. Okay, so this is the given differential equation is in variable separable form. Okay, now once it is in variable separable form, you can find its solution. Okay, and its solution is given by integrating on both sides, taking integration. So this will be integration x square dx plus integration y cube dy is equal to constant. Okay, now you know integration of x square is x raised to 3 upon 3 plus integration of y cube with respect to y is what? Y to the power 4 upon 4 equal to c. So this will be our final solution for the given differential equation. Okay, I hope it is clear now. Suppose we will solve some examples. Okay, we have this example to solve this differential equation. Okay, to solve such a differential equation, first we need to identify whether this is in variable separable form or not. Okay, so if you'll see here dy, and in dy what should be there? Strictly in dy what should be there? The function of x alone. Okay, if you observe here, okay, dy coefficient should be function of y alone and dx coefficient should be function of x alone. Okay, if you'll observe in our given example, okay, the coefficient of dy is x and the coefficient of dx is y. Okay, so we need to simplify it first. Okay, so I will rewrite this as x dy is equal to y dx. Okay, so take y terms to the one side and x terms to the other side. So this will be 1 by y dy is equal to 1 by x dx. Okay, now this differential equation is in variable separable form. This differential equation is in variable separable form. So why is it in variable separable form? Because this is a function of y alone dy and this is function of x alone dx. Okay, so integration 1 by y dy is equal to integration 1 by x dx. Okay, and some constant, suppose I will take that constant as log c. Okay, so integration of 1 by y will be log y and integration of 1 by x will be log x plus log of c. Okay, now we know the rules for logarithms. Okay, we know the rule for logarithm, what? Log of a plus log of b is what? Log of a into b. Okay, so we can write this term as log of x into c and this will be log of y. So from both sides this log will get cancelled. Okay, so what we get? We get the final answer is equal to y equal to x into c, and that is what our solution is. Okay, now in the next example, okay, if you'll observe here, this is not in variable separable form, so we need to convert it to variable separable form. So means what? Function of x into dy into dx equal to function of y into dy. Okay, so this will be like e raised to y dy equal to x square dx. Okay, so this is what we will do. This is our function of x dx, function of y dy. So this is in variable separable form. Okay, so once it is in variable separable form, what we do? We find its solution by taking integration on both sides. Okay, so this will be integration e raised to y dy equal to integration x square dx plus some constant c. Okay, now integration of e raised to y dy with respect to y will be e raised to y, and integration of x square with respect to x is x cube by 3 plus c. Okay, so this will be like this, e raised to y equal to x cube by 3 plus c, and that is our final solution. Okay, now in the next example, if you again observe here, the coefficient of dx are function of x and y both, and also the coefficient of dy are function of x and y both, but we can separate it. Okay, now how to separate it? Just rewrite the given example, x into 1 plus y square dx is equal to minus y into 1 plus x square dy. Okay, now take x terms to the one side and y's terms to the other side. So this is y terms, okay, and this is x terms. So take it to the other side, either of the side. Okay, so this will be like x dx. Take this 1 plus x square to the left side. This will be 1 upon 1 plus x square. Okay, and this will be minus y upon 1 plus y square into dy. Now this is our differential equation in variable separable form. Okay, now once this is in variable separable form, what we do? We just find its solution by integrating on both sides. Okay, so integrating on both sides, this will be x upon 1 plus x square dx is equal to integration minus y upon 1 plus y square dy equal to some constant. Suppose I will take that constant equal to log c. Okay, now to solve this integrating term, okay, we need to use one formula here. We have seen this in the integration. What is that formula? If the terms are like this, f dash of x upon f of x dx, okay, its answer will be log of f of x plus c. Okay, now what it means, if you have the terms inside the integration, like if denominator contain the function and the numerator contain its derivative, then its integration will be log of that function. Okay, now in this case what we have, our derivative of 1 plus x square is what? If you'll observe here in this term, okay, in this term, if you'll observe, our function f of x is what? 1 plus x square, and we know the derivative of f of x is f dash of x, that is what? 2x. Okay, so what we will do, we have 1 plus x square here. Okay, if you'll observe here, we have 1 plus x square, that is f of x. Okay, and what is this? This is f dash of x. But f dash of x is not directly given. We need this extra 2 here. So multiply and divide that term by 2. So this will be 1 by 2 integration 2x upon 1 plus x square dx. Okay, minus, similar way to the right side, integration derivative of this term. Derivative of 1 plus y square is 2y. But what is there? Only y. So multiply and divide by 2. So this will be 1 plus y square dy plus log of c. Okay, so using the formula, which formula? This formula. This is now in the standard form. Okay, so its answer will be 1 by 2 log of f of x, that is what? Log of 1 plus x square. This is equal to minus 1 by 2 log of 1 plus y square plus log of c. Okay, now if we will rewrite this, okay, I will take it to the next page. Okay, so this is our integrating term. Okay, we need to just simplify this. Okay, I can write this as log of 1 plus x square raised to half is equal to log of 1 plus y square raised to minus half plus log of c. Okay, which formula I have used here? The property of logarithm, a into log of b. A into log of b is what? Log of b to the power a. That is what I have done. This is a and this is b. So this will be log of a to the power b. Okay, so finally, again using some logarithmic rules, this will be log of 1 plus x square to the power 1 by 2 is equal to, now this is log of a plus log of b. So this will be log of 1 plus y square a into b minus half into c. Now this log will get cancelled. So what remains? This will be 1 plus x square to the power 1 by 2 is equal to 1 plus y square to the power minus 1 by 2 into c, and this is what our answer is. Okay, now in the next example we need to solve this differential equation. Okay, so we will try and convert this differential equation to the variable separable form. So this will be dy by dx is equal to, I will write this e raised to x minus y as e raised to x into e raised to minus y plus x square into e raised to minus y. Now if you will observe, this e raised to minus y is the term present in both the terms, so I will take it out. Okay, so what remains in bracket? E raised to x plus x square. Okay, so now what will happen? What we have got? We got dy by dx is equal to e raised to minus y into e raised to x plus x square. Okay, now we can separate the terms of y and terms of x. Okay, so see what will happen. This will be dy upon e raised to minus y. This term will come to the LHS at the denominator, and this dx will go up to the multiplication term to the given bracket. Okay, now this is, again I can simplify this. The e raised to minus y will go in the numerator as e raised to y into dy equal to e raised to x plus x square dx. Now this is our differential equation in variable separable form. Okay, so that we can find its solution. Okay, and its solution is given by integrating on both sides. So integration dy e raised to y dy equal to integration e raised to x plus x square dx plus c. So integration of e raised to y with respect to y is e raised to y equal to integration of e raised to x with respect to x is e raised to x. Integration of x square with respect to x is x cube by 3 plus c, so that this will be our final answer. Okay, next example is to solve this differential equation sec square x into tan y dx plus sec square y tan x dy. Now we will try and convert this differential equation to the standard form of variable separable form. Okay, so we will rewrite this as sec square x tan y dx plus sec square y tan x dy is equal to 0. Okay, now if we'll observe again, what will happen? We can write this as sec square x tan y dx is equal to, take this term to the RHS, this will be minus sec square y tan x dy. Okay, now if you observe in the LHS the term is dx, means we need only the function of x, so this term tan y is extra, and in RHS term is dy, so we need only the function of y, so this term tan x is extra. Okay, so take this tan y to this side and this tan x to this side. Okay, see what will happen. This will be sec square x upon tan x dx is equal to minus sec square y upon tan y dy. Okay, now this is in variable separable form. If you will observe here, this is a function of x dx and this is function of y dy. Okay, so we can find its solution by just integrating on both sides. Okay, so integrating on both sides. Okay, so after integration, what you will see, this will be like integration sec square x upon tan x dx equal to minus integration sec square y tan y dy plus suppose log c. Okay, now whatever this integration is, we can solve this using integration f dash of x upon f of x dx. Its answer is what? Log of f of x plus c. Okay, so this is our function tan x and derivative of tan x is sec square x. Okay, so the answer for first integration will be log of tan x. Okay, again this is our function tan y and its derivative is sec square y, so this will be like minus log of tan y plus log of c. Okay, so this is like log a minus log b, so this will be log of c upon tan y, and this is equal to log of tan x. Okay, now cancelling log from the both sides. Okay, so finally what we will get, you will get this as tan x is equal to c upon tan y, and that is our final solution. Okay, now in this example, if you'll observe here, see, we can solve this differential equation, but to solve using the variable separable form, we need the function of x dx, function of y dy. If you'll observe in this case, the x and y terms are mixed, but we can separate it. Okay, from the first term I will take y out, what remains 1 plus x square dy by dx. Okay, I will take this term to the right side and will take x out, so what remains 3 plus y square. Okay, now take this dx to that side. Okay, see, and this y term to the left side. Then what we will get, this implies y upon 3 plus y square dy is equal to x upon 1 plus x square dx. Okay, now clearly this is in variable separable form, function of y dy, function of x dx. So find its solution just by integrating on both sides. Okay, so this will be integration y upon 3 plus y square dy equal to integration x upon 1 plus x square dx plus, suppose, log c. Again we need to use the derivative function upon its derivative formula. Okay, which one? We have this formula, integration f dash of x upon f of x dx is what? Log of f of x plus c. If you observe here, the derivative of 3 plus y square is 2y, so we need to adjust 2 here, so this will be 1 by 2 integration 2y upon 3 plus y square dy equal to, again the integration derivative of 1 plus x square is 2x, so we need to adjust 2 here also. This will be 2x upon 1 plus x square dx plus log c. Okay, so this will be equal to, so integration of this term will be log of 3 plus y square is equal to 1 by 2 integration of this term will be log of 1 plus x square plus log c. Okay, so finally I can rewrite this as log of 3 plus y square to the power 1 by 2, and this will be log of 1 plus x square to the power 1 by 2 plus log c. Okay, so finally this will be log of 1 plus x square to the power 1 by 2 into c, and finally this log and this log cancel, so we get the answer as 3 plus y square to the power 1 by 2 equal to 1 plus x to the power 1 by 2 into c, and that is our final answer. Now in this example, okay, we need to again convert this to variable separable form, so I will rewrite this as dy by dx is equal to e raised to 2x into e raised to minus 3y plus 4x square into e raised to minus 3y. So this is equal to e raised to minus 3y e raised to 2x plus 4x square. Okay, so what we will do, we will convert it to the variable separable form. So take this y terms to the left side, see what will happen. This will be dy upon e raised to minus 3y, and take this dx to the right side. So this will be e raised to 2x plus 4x square dx. Okay, now this is in variable separable form. We can simplify. E raised to minus 3y is in denominator, so it will be like e raised to 3y in numerator into dy e raised to 2x plus 4x square dx. Okay, this is now in variable separable form. So find its solution by integrating on both sides. So integrating on both sides, this will be integration e raised to 3y dy equal to integration e raised to 2x plus 4x square dx plus c. Okay, now integration of e raised to 3y with respect to y is e raised to 3y upon 3 equal to integration of e raised to 2x with respect to x is e raised to 2x upon 2 plus integration of e raised to 4x square is 4x to the power 3 upon 3 plus c. Okay, now we will multiply this whole equation by LCM of 2 and 3, that is 6. So multiply by 6. Okay, so this will be 2 into e raised to 3y equal to 3 into e raised to 2x plus this will be 8 into x raised to 3 plus 6c. Okay, and this 6c can be another constant, suppose c dash. Okay, and that is our final answer. Okay, one more example to solve this differential equation. Now again we will try and convert this to the variable separable form. So we can rewrite this as e into 3 into e raised to x tan y dx is equal to minus 1 minus e raised to x sec square y dy. Okay, so take x term to one side and y terms to other side. So what is extra term here? Tan y. And what is extra term here? 1 plus e raised to x. So take to the one side. So this will be 3 e raised to x upon 1 minus e raised to x, okay, dx is equal to minus sec square y upon tan y dy. Okay, now again this is in variable separable form. Okay, so once it is in variable separable form, this will be integration 3 e raised to x upon 1 minus e raised to x dx is equal to minus integration sec square y upon tan y dy plus constant. I will take this constant as suppose log c. Okay, again by using this formula, integration f dash of x upon f of x dx is equal to log of f of x plus c. Okay, means what? In denominator there should be function, okay, function f of x, and numerator there should be function derivative of that function. Now we know the derivative of this term, that is derivative of 1 minus e raised to x is what? 1 minus e raised to x derivative is minus e raised to x. Okay, but we have only e raised to x, so we need to adjust this minus sign. So what we will do, this 3 is constant, okay, so adjust this minus sign, okay, like this will be minus e raised to x, minus will be plus upon 1 minus e raised to x dx is equal to minus. Now it is clearly tan y is a function and sec square y is derivative, so this will be, answer will be log of tan y plus log of c. Okay, so what will happen, this will be minus 3, integration of this will be log of 1 minus e raised to x, this will be log of tan y to the power minus 1 plus log of c. Okay, so finally I will write the LHS as log of 1 minus e raised to x, this minus 3 will go here as minus 3, this will be log of tan y to the power minus 1 into c. Now again this log and this log cancels, so what remains? 1 minus e raised to x to the power minus 3, and this will be tan y equal to tan y to the power minus 1, okay, into c. Okay, so finally this will be our answer. Okay, next example. Okay, to solve this example, the given example is like this. Okay, we have to convert this to the variable separable form so that we can get its answer directly. So this will be y minus x dy by dx is equal to a y square plus a dy by dx. Okay, now see what will happen. I will take the dy's term to one side and the single term to the other side. So this will be a dy by dx. This minus will become plus here. So this will be plus x dy by dx. Okay, and to the LHS what will happen? This is y already there, minus a y square. Okay, so I will take this y out from this. This will be 1 minus a y is equal to, I will take dy by dx term out. Okay, so this will be dy by dx. Now this is a function of y alone, this is a function of x alone. Okay, so rewrite it as a variable separable form. So after rewriting, what you will see, this will be 1 upon a plus x into dx is equal to 1 upon y into 1 minus ay dy. Okay, now this is in variable separable form, clearly variable separable form. Okay, now once it is in variable separable form, what we do, we find its solution just by integrating on both sides. This will be 1 upon a plus x dx is equal to integration 1 upon y into 1 minus ay dy plus suppose log c. Okay, now to take this integration we need to use the partial fraction, and we have studied what means partial fraction in the first chapter. Okay, so after using the partial fraction I will get the terms like this. This will be 1 by y minus 1 upon 1 a upon 1 minus ay. Okay, so this will be plus, okay, dy plus log c. Okay, now we can take the integration directly. The integration of this term is what? Log of a plus x, because derivative of a plus x is 1 with respect to x. Derivative of 1 by y with respect to y will be log y, and derivative of this term with respect to y will be minus log of 1 minus ay plus log c. Okay, now this is like log of a minus b. Okay, this term, so this will be log of a upon b, okay, plus log c. So finally we can write this as log of, this is like log of a plus log b, so that will be log of a into b, so this will be y into c upon 1 minus ay. Okay, now finally we can cancel out this log term. Okay, so what remains? A plus x is equal to y into c upon a 1 minus ay, and that is our final answer. Okay, and this is how we find the solution of any differential equation if it is in the variable separable form, just by integrating on both sides. Thank you.